Okay, so let's keep going. Before the break, we talk about the radiation therapy. And that's because of isotope. Okay, let's practice one question. The question asks you, okay, most common form of calcium has 20 proton, 20 neutron, 20 electron. And the question asks you, which of the following would be the isotope of calcium? So in your exams, I have multiple choice questions. Okay, this could be one question or one similar one. So I ask you, what's the isotope? And it's calcium. And I tell you calcium has 20 proton. And based on this, you know isotope is the same atom. It's the same atom of calcium. This time I ask you calcium. So calcium need to have 20 proton because its atomic number need to be 20. If it's not 20, it's not calcium. So far, so good. Okay. So if it's not 20, they are not correct answer. So you can cross B and C out. Means you can cross E out. Because its isotope is still calcium, it need to be the same number of, it need to have the same number of proton. So answer will be either be A or D. And let's keep looking. So A and D, the difference is, okay, one have 21 neutron, the other have 20 neutrons. And we know isotope would be the same proton, different electron. So A is the correct answer. A is correct answer. Then what's D? D has 20 proton, 20 neutrons, and 18 electrons. And I told you the charge is supposed to be balanced. Proton has positive charge, electron has negative charge. So this guy actually has 20 positive and 18 negative. So together, the charge of this molecule is actually positive 2 because it's 2 more positive. So what's D? D is the one we are going to talk about. It's called ion. It's calcium ion. It's positive 2 charge because its proton number and electron number are not the same. So D is calcium ion. A is the calcium isotope. Okay, now the third one, let's look at the electron. I told you electron give the atom its personality because electron is the one will interact with the other. So let's look at electron. Electron has negative charge and it does not stay in the nucleus, stay outside. We call the shell. We call the shell. So the structure of the atom is actually very similar to our solar system. The nucleus, that's the sun, and each planet stay in its orbit. It's like electrons stay in the shell. Okay, now let's look at the electrons because electron give the atom its personality. So each shell can hold different number of electrons. Shell number 1 is a small shell. It can hold 2. And once you have 2 electrons, the third one have go to the layer number 2. So the second layer can hold 8. And if they reach 8, the next one have go to the third layer. The third layer can hold 8 or 18. If you took chemistry, they can tell you, especially when the shell become bigger and bigger, they can have exception. But for this class, let's keep it simple. Let's just say 8. You can forget 18. I won't ask you the 18. So the first layer you can have 2. The second layer you can have 8. The third layer you can have 8. So it's called the octet rule, also called the 288 rule. I like to call it the 288 rule because it helps my student to remember how many electrons you can put in. So the first layer of shell, you can put 2. The second layer, you can put 8. The third layer, you can put 8. And you say, how about the fourth, the fifth? I won't ask you more than that. Remember, this is a biology class. We use the chemistry knowledge to help us to understand biology. So I will ask you simple atoms, means no more than 3 layers. If you want to learn more, you can take chemistry. Okay, so now we can look at the periodic table. You find this time, this periodic table draw the atom structure. And hydrogen number 1, so he has 1 proton. He has 1 proton, he must have 1 electron. So the shell, 1 electron, first layer, 1. That's it. So hydrogen is the simplest atom. And let's look at helium. Helium is number 2. Number 2 means 2 proton. And it also has 2 electrons, right? 2 electrons. So 2 can put into layer 1 shell. Okay, number 3, lithium. 3 protons, 3 electrons. First layer put in 2 electrons, and the third one have to go to the second layer. And then you find number 4, number 5, number 6, number 7. Their proton number keep increasing, so their electron number keep increasing as well. And there's electron just keep adding to the second layer, to the second layer, to the second layer, until it go to neon. Neon atomic number is number 10. Number 10 means 10 proton, right? That's why it's number 10. And his 10 proton must have 10 electron. 10 electron. So first layer 2, second layer 8. And it's full. It's full. And then if you have 11, the next one have go to the third layer. That's this one. Third shell, like the sodium. Sodium atomic number 11. So you find here's 11 proton, 11 electron. So those 11 electrons, the first layer 2, second layer 8, the third layer is 1. And keep filling, keep filling. And you find the periodic table is organized in this way. The column, each columns, actually the outer layer of shell, you find they are the same. And they are the same, they have the same personality. Told you electron give them personality. That's why they put it in the same column. And the last column, you find the outer layer is full because the heliums, the first layer of shell, it can only have 2 and it fills with 2. Neon, the outer layer shells have 8. You can only have 8. It's full. And the argon, argons has 18. So first layer have 2, second layer have 8, the third layer have 8. It's full. So all this, we call them noble gas. Because all these molecules, the electrons, shells are full. They're very stable. So each columns, their elements have the same personality. Okay, so I told you the electron give them their personality. And the outside layer, especially the outside layer, could be layer 1 if he only has 1 layer, like the hydrogen, heliums, then his outside layer is this layer. So, and for the one with 3 layers of shell, the outside layer is this one. The electrons stay in the outside layer is called valence electron. So like this atom, if I ask you, okay, how many valence electron? The answer will be 4. 1, 2, 3, 4. Because they are the one can have interactions with other atoms. The inside one, they are stable. They just stay there. So the outside is called the valence. It's called valence. And I told you electron give them their personality because the valence electron is the one have chemical interaction with other. So you find all on the periodic table, the same column. These elements, they have the same, very similar, they call them chemical characteristic. I call them personality because their valence electrons are the same. So the first column's valence electron will always be 1, and the second column will be 2. And the 7s, the 8s, especially the 8s, all the valence, they are full. The helium has 2, neon has 8, argon have 8. So that's how the periodic table is organized. Okay, so the question I will definitely ask you on the test is, so far we talk about those 3, protons, electrons, neutrons. Okay, I give you any atoms Would you be able to tell me all this information? I will ask you this in the test. So let's do the practice. So in the test, I'll give you this picture. I will give you this one, but probably I won't, because if I give you actions 8, 16, I give you these two, and then you should be able to tell me everything else. You can also draw this. You can also draw this. Oh, and the small number is atomic number. The bigger number is atomic mass, or atomic weight is actually atomic weight. So what's the difference between atomic weight and atomic mass? Atomic mass is number of proton plus neutron. So atomic mass will always be the integer. And what's atomic weight? Atomic weight is you have to consider the isotope. Remember carbon, say we have carbon 12, carbon 14, right? So you have 99.9% carbon 12, and you still have 0.1% carbon 14. So you have to consider them, use 99.9% multiplies 12 and plus 0.1% multiply 14. So you get something with decimal. And excuse me, that's the atomic weight. So atomic weight is one with a decimal point, not the integer. But when you look at this, you can tell you know what's the main form of the each atom. Like this one, you find the oxygen is very close to atomic weight is closer, very close to 16. Means is atomic mass. The main form is atomic number 8, and its mass is 16. Okay. So 8, 16. Okay. So what's the number of proton? Number of proton will be 8, right? I give you this. In the test, I'll give this. The number of proton is 8. Okay, number of neutron. Neutrons is used 16 because the total number is the weight is 16 minus 8. So it's 8. Number of neutron is 8. And number of electrons. Electron is the same number of proton. So proton is 8, electron will be 8. So what's the atomic number? 8. What's the atomic mass? 16. 8 plus 8, 16. Number of valence electron. Okay, we have to draw their structure. And when we draw this atomic structure, the first layer you have 2, and then total number of electron is 8. Second layer is 8 minus 2, 6. So number of valence electron will be 6. Name of this atom, oxygen, chemical symbol, O. So far, so good? Okay. Let's take a short break.